All right. So this is the third part and the final part of metals and non-metals today. We're going to learn about. Okay. So I want you all to tell me what we learned in the first class. What are the physical properties of metals that we learned?
Ma'am, can I tell all of them?
Okay, Sriram. Yeah, you say one. Everyone should say at least one. Then I'll come to you for the rest. Okay?
Ma'am, metals have luster, ma'am. They're lustrous.
All right. Yes. So one by one, Janvi, Sakshi, Nishraya, you all can say one property of metals.
They are sonorous.
Yes, sonorous. All right. So, and the opposite will be for non-metals, right? If metals are lustrous, non-metals will be non-lustrous. If they are sonorous, and non-metals will be, they won't be sonorous. Okay. Sakshi and Janvi, can you all tell me one physical property of metals and non-metals?
They're malleable. Malleable.
Okay. So metals are malleable and non-metals are not malleable. Sakshi, can you come up with one property?
Yes, ma'am. Just a second.
Yeah.
Lustrous.
Okay, Shriram just told that property. He said that metals are lustrous. Any other property that you can come up with?
Ductile.
Yes, they are ductile. Okay, so metals are ductile and non-metals are not ductile. Shriram, can you tell me the other properties which are not yet which are not yet said by the others?
They're sonorous.
Sonorous already Nishraya said. Any more properties that you all remember? They are good conductors of what?
Ma'am, heat and electricity.
Good conductors of, yes, they're good conductors of heat and electricity. Okay, they are hard. So these are some of the physical properties of metals. Okay, and the reverse will be for non-metals. Okay. All right, tell me which gas was evolved out when metals reacted with oxygen. What was the gas that we tested for by putting the matchstick? What was the gas that was being evolved out?
Ma'am, can I say?
Yes, Shriram.
Ma'am, hydrogen.
Yes, very good. So hydrogen gas was being evolved out. That's why the matchstick burnt with a pop sound. Okay. All right. So these are the things that we discussed in the previous two classes. We also discussed about the chemical properties of metals and non-metals. So how metals reacted with oxygen, acids, and bases. Okay, and how non-metals also did. So we discussed all these things. Next slide. All right. We already covered up these things. Yeah. So we move to today's topic, that is displacement reaction. What do you understand by displacement? Have you heard the term displacement before? What do you mean by displacement? Yes, Janvi?
It's like replacement. You displace something.
Yes. So like something is being replaced for another thing. Okay. So it can be called displacement. Or displacement, we can say it is moving from one place, it is being displaced, like we shift something. Okay, for example, there's a bottle on top of the table in front of me. I displace it, I put it somewhere else, so that is displacement. All right. Now, what you'll understand by looking at the picture, tell me. There is something before the arrow and something after the arrow. Now, what you'll understand by looking at the picture, what you all can interpret from the picture, you all tell me. Who can tell me what, by looking at this picture, what are you all being able to interpret? Yes, Chanvi.
Boy plus the boy and the girl plus the other boy is the same as the boy and the girl plus the other boy.
Okay. All right. So something. Okay, you gave your thought. Anyways, any other interpretation that you all can do? Yeah, that's actually the same thing, but how is displacement coming in between? Like, how is displacement coming into the picture then? So that thing can tell me.
The f-
Can
the
anyone
first boy
interpret
is
and tell
being
me?
replaced. The first boy is
Yes,
being replaced by the second one.
yes, yes. So that is exactly what we're going to study today. Okay, we are going to study about a displacement reaction. You can see a thin boy, okay, and they both are friends. For example, you can see the boy with the yellow t-shirt and the girl, okay, they both are good friends. Now there's another boy who is very, you can he's very like his, he's very fat and he's strong, you can say, okay. So what he does, he comes and displaces the first boy, and he becomes the girl's friend now, and he pushes the other boy away. Understood? So this kind of a reaction is called a displacement reaction. Now the first boy is weak and the second boy is strong. We can say the first boy can be like a weak metal, and the second boy can be like a strong metal. So when a weak metal forms a compound and a strong metal is also added to it, the strong metal can displace the weak metal. Did you all follow what I'm trying to tell you all? There's a weak metal that has formed a compound. Okay, like the girl is the boy and the girl both are forming a compound. The first case which you see, the boy with the yellow t-shirt and the girl, okay, they're forming a compound, but the boy is a weak metal, so the weak metal is forming a compound. Now there is another strong metal that is coming into the picture, that is the boy with um, the red t-shirt, okay, he's now coming into the picture, he's a strong metal. Now when there is a combination of this weak compound and a strong metal, then the strong metal will displace the weak metal and it will form the compound. So that the same thing is happening. The boy with the red t-shirt is forming the compound now, and it displaces the boy with the yellow t-shirt. Means the weak metal gets displaced in the presence of a strong metal. Did you all understand the displacement reaction? If a weak metal forms a compound and a strong metal is added to it, then the strong metal will displace the weak metal from it, and it will form a compound. Okay, so this type of a reaction is called a displacement reaction. See what it says. Displacement reaction is a chemical reaction in which a more reactive element, a more reactive element means a strong metal, we can say. Mostly reactivity is for metals, okay? So a strong metal displaces a less reactive element, displaces a weak metal from its compound. All right? When there is a strong metal and a weak metal together, the strong metal will always displace the weak metal. So that kind of a reaction is called a displacement reaction. Is it clear to everyone? Is it clear what is the meaning of a displacement reaction?
Yes, ma'am.
Okay. Shriram and Sakshi, have you all understood?
Yes, ma'am.
Sakshi?
Yes.
Okay. So we move on to the next slide now. Okay. So there are some examples, okay? For example, magnesium and copper sulfate. We can say copper sulfate. Now, copper is a metal, okay? And it forms a compound that is copper sulfate. There is another metal that is magnesium. Now, here, tell me, I'm telling the first one, the other things will be told by y'all. See, first one, there is a compound formed by copper, which is copper sulfate, okay? And there is another metal which is being added to it, that is magnesium. Now, magnesium is stronger as compared to copper. So what happens then? Magnesium displaces the copper. Copper goes out, magnesium forms a compound with sulfate group and it forms magnesium sulfate. So here magnesium is a stronger metal. Magnesium forms a compound with sulfate and displaces the copper. You'll follow this type of a reaction? Did you all follow the first reaction?
Yes,
Okay.
ma'am.
Yeah. So now I'll ask you all, now look at the second reaction, all of you. Okay, I'll be asking you all some things which you all have to answer. Now this is zinc plus iron sulfate will give zinc sulfate and iron. Now tell me, Shriram, which is the stronger metal here in this case?
Ma'am, in which one, ma'am? In which case?
In the second reaction, which is
Ma'am,
the stronger metal?
ma'am, zinc.
Zinc. Very good. So zinc is the stronger metal. Tell me which metal is being displaced?
Ma'am, zinc. Sorry, ma'am.
Which
Sorry,
one?
iron. Ma'am, iron.
Iron. Yeah. Iron is being displaced. So you can see it like in the product side, you can see iron is, zinc is forming the compound that is zinc sulfate and iron is displaced away. Okay. Now, Nishraya, tell me in the third case, which is the strong metal?
Magnesium.
Magnesium is the strong metal. And which
Yes.
metal is being displaced?
Zinc.
Zinc. Very good. Okay. Now, Sakshi, you tell me, which is the strong metal in the fourth case? Which is a strong metal? Now the metals names are written below. Okay, magnesium plus iron sulfate gives magnesium sulfate and iron. You have to tell me, Sakshi, which is a strong metal out of, there are two metals. So which is a stronger one as compared to the two?
Iron.
Okay. Janvi, what do you say?
Magnesium is a strong metal and iron is a weak one.
Yes. So magnesium is a strong metal, therefore it displaces the iron and iron is a weak one. All right, did you understand what is the meaning of a displacement reaction? The weaker metal is displaced, stronger metal forms a compound. Is that clear to everyone?
Yes, ma'am.
Okay.
Yes.
So we move on to the next slide now. Okay. So there is something called a reactivity series. How do we know what is strong and what is weak? We don't know what is strong and what is weak. We have never seen those metals. We don't know what is the how does it react with other metals. Okay, so there is something called a reactivity series. Okay, this reactivity series will tell us which metal is stronger and which is weaker, which is more reactive, which is less reactive. So all of you need to note down this reactivity series. Okay, if you all don't have a pen and a notebook, please collect it fast, and you have to note this down. A reactivity series, the reactivity series, you'll have to note it down. You'll have to note which is on the left hand side. Okay, that is potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, and platinum. So this is what you have to note. Note it down, then I'll tell you all more about it. When you have noted it down, then you'll tell me that you have finished. All of you need to note it down, because I'll be asking you all a few questions on the basis of this reactivity series, and you all will have to give me an answer for that. Okay, so all of you take a note of the reactivity series. Okay, one more thing I wanted to ask you all. Do you all know the symbols for the elements? Do you all know the symbols? What are the symbols? Okay, Janvi. Nishaya?
A maximum of them.
Okay. So you all can note down the symbols also beside them. Okay? So, who all are done with it? Janvi is done. Okay. Anyone else who's done? Come on, you all need to be faster.
I finished writing too.
Okay. So what is this reactivity series? It's a series of metals, okay? And this reactivity series tells us which metal is more reactive, which is a stronger metal, and which is a weaker one. So when you compare the metals, you can know which is a stronger metal as compared to the other one, okay? You can know which will react more and which will react less. So according to that, they are in a hierarchy, okay? So it tells us which is more reactive and which is less reactive. You all can see the metals at the top, they are most reactive, and the metals, as we go down, the metals become less reactive. All right, Nishaya and Shriram, have you noted it?
Yes, ma'am.
Okay. Shriram, what about you? Okay. So how you all can remember it? If now on the right hand, on the left hand side, like beside potassium, you all write, you all write, you all write, please, on this. How you all can remember it easily, because there is always a chance that you all forget. Okay. the reactivity series. So how we can remember it easily? So you'll write please. In sodium, you'll write send. In place of calcium, you can write Charlie's. Charlie's. Charlie. In place of M, you can write monkeys. In place of A, you can write and. In place of carbon, you can write cute. In place of zinc, you can write zebras. In place of iron, you can write in. In place of tin, you can write tall. Tall. In place of lead, you can write large. In place of hydrogen, you can write huge. For copper, you can write cages. For silver, you can write securely. Securely. For gold, you can write guarded. And for P, you can write please. So what does it say? Who will read it out? Yes, Janvi.
Please send Charlie's monkeys and cute zebras in tall, large, huge cages securely guarded, please.
Yeah. So this is the way that you all can remember it easily. Okay. In case you'll forget which metal is more reactive and which metal is less reactive, this is the way you all can remember it easily. You all can recall it. Okay. So have you all noted it down? You all can make your own way of remembering. Okay, it's not a hard and fast rule that you all have to remember it like this. If you all think of something else in to write for all these letters, then that is yours wish. Okay, but this type of a learning of the reactivity series makes it easier for you all to remember it. Think about the symbols now. Okay, we can also remember the symbols easily. You all can write in place of K, like you all have written the symbols, right? On the right hand side, K, N, A, C, A, N,
Yes.
G. Yeah. So you all can write which from the screen. Okay. It's in Hindi, but you all can write it. You all can remember it also easily. So K for Kal. NA for Nathuram. CA for Ka. And underline the the alphabets. Okay. MG for manager. It's in green. Underline the alphabets, which are the symbols. So MG for manager. AL for Aladdin. CE for say. There's a carbon. Okay. ZN for Zen. FE for Ferrari. SN for Sona. PB for Pav Bhaji. H for Hira. CU for Chiraya. AG for Aj. AU for Or. PT for Pita. Okay. So this also, you all can remember the symbols also easily. Okay, by making something that makes it easy to remember the reactivity series in a sequence. Because if you all do something wrong in the reactivity series, yours entire reaction can be wrong. Okay, so you'll have to remember it in a sequence. This has to be remembered in a sequence. So who will read it? What does it say? Who will read it? Yes, Janvi.
Um,
Okay, Nishaya.
यस मैम। कल नथुराम का मैनेजर अलादीन से जैन फरारी सोना पाव भाजी हीरा चुराया, आग और पीता।
हाँ, आज और पिटा. Okay.
ओ आज और पिटा।
Yeah. So you all can remember it like that. Okay. The symbols you all can remember. You all can also remember the names. So this is the way you all can remember the reactivity series. Now you all tell me. Look at yours wherever you all have noted. Tell me if there are two metals, that is magnesium and copper, then which will displace which metal? Which metal is going to displace which metal? If there are two metals, magnesium and copper, which metal is going to displace which metal? Yes, Janvi. Hello? There is a lot of disturbance.
Can you hear me now?
Yes.
Is it better?
Yeah.
Yeah, okay. Magnesium will displace copper.
Okay. Magnesium will displace copper. Now the second question for Sriram. Sriram, are you there?
Yes, ma'am.
Okay. Now, if I take two metals, that is iron and silver, so which metal is going to displace which metal?
Ma'am, iron will displace silver. It's all.
Silver. Yeah, iron will displace silver. Okay, very good. Now, Nishraya, if I'm taking two elements, that is carbon and sodium, which is going to displace which metal? Which is going to displace which one?
Sodium will be displacing carbon.
Okay, very good. Sakshi. Okay, so you say Sakshi and Sakshi has left. All right. You all understood the reactivity series now? Which one is going to displace which element? By looking at the
Yes.
reactivity series, can you all tell us? Yes or no?
Yes, ma'am.
Okay. All right. So this is from the reactivity series, we come to know which metal is stronger as compared to the other metal. Which metal is going to, which metal can displace another metal. Okay. And you all can see all our metals except two, that is carbon and hydrogen. Carbon and hydrogen are non-metals. Now, why are they put into the list of metals? Can anyone guess? See, let me tell you all. They are put in the list of metals so that we can compare. Okay, we can compare anything with iron, like above it and below it. There, like it forms three groups. Potassium to aluminium is one group. Carbon to lead is another group. Hydrogen to platinum is another group. Okay, so potassium to aluminium, they are most reactive elements. Carbon to lead, they are moderately reactive. And hydrogen to platinum, they are the least reactive elements. Okay, so it divides the entire reactivity series into three parts. The most reactive, moderately reactive, and the least reactive elements. Is that clear?
Yes,
Okay. So now we move on to the experiments. All right, all right. Before that, see, now you all will look at your reactivity series, okay? Now there are two men. In the first case, that is magnesium and copper sulfate. So from magnesium and copper, which is more reactive, tell me? Who will tell me?
Magnesium.
Magnesium is more reactive. Therefore, magnesium forms a compound with the sulfate group and it becomes magnesium sulfate and copper is displaced. Okay? Now, who will tell me in the second reaction why there is no reaction? No reaction happens. Why is it so? In the second case, no reaction happens. Why is it so?
Ma'am, because the silver is
Yeah.
less reactive than copper.
Okay.
That's
So
why
it
there's no
cannot
reaction.
displace.
Yes,
Yeah.
it cannot
So
displace copper.
it cannot displace copper. Therefore, there's no reaction. All right. In the third case, the same thing happens. Calcium is more reactive than zinc. So calcium displaces the zinc and forms a compound with the sulfate and forms a compound that is calcium sulfate. Okay. And in the fourth case, the same thing happens. What is that? Iron is less reactive as compared to zinc, so it cannot displace the zinc. Therefore, no reaction happens. Did you all follow all these reactions? How it takes place?
Yes.
Okay. So now we move on to the experiments, okay? Yeah. First one will be the displacement reaction. Now, I'll show you before. For what we have to do is, we have to take copper sulfate. We are now going to conduct an experiment by adding copper sulfate with iron. Okay, so this is copper sulfate. How does it look like? You all can see. Can you all see it?
Yes.
What is the color?
Blue.
Blue. Okay, so now we have to make a solution of copper sulfate. Okay. Copper sulfate solution is blue in color. Can you all see the color changing a little? It's becoming blue. Can you all see the color? It has not yet dissolved fully, so it will take time. So, see, this will become blue in color, like this one. Can you all see the color?
Yeah.
Yes.
This is copper sulfate solution, okay? Now, copper sulfate solution is blue in color. Now, when you put an iron nail into the copper sulfate, is the solution still blue?
No.
What is the
Nicola ma'am, can you
Yeah.
have something at the background of the test tube? Maybe a sheet of paper or something, a notebook.
A sheet of paper. Can you all see it now?
We can see it, but then the deposition won't be seen clearly. That's why. If it's a clear background, it'll be seen.
Everything is white actually. The deposition, I'll show them by removing the nail. Only I want them to see the solution now. What is the color of the solution? Is it still blue? This is copper sulfate.
It's almost transparent.
Yeah, it's almost transparent. Okay. So the copper sulfate has changed color. All right. Now I'll show you what has happened on the nail. Give me some time. Can you all see this?
Yeah.
Yeah. Can you all see something is deposited on the nail?
Yes.
Something which is, what is the color of that which is deposited
Red.
on the nail? Yeah.
Red.
So can anyone guess and tell me what is that which is deposited on the nail? What had happened?
Ma'am, copper is deposited on it.
Yes, very good. So copper is deposited on the iron nail because which is a more reactive one? Iron or copper? See your reactivity series.
Ma'am, iron is more reactive.
Okay, so iron is more reactive. So iron forms a compound, okay, with the copper sulfate, that is iron sulfate. And what is this which is deposited on the iron? That is a copper. Copper is deposited. Copper is displaced. Okay, so copper gets separated out. Out of the copper sulfate, the copper gets displaced. It is getting separated out, and the iron forms a compound with the sulfate. That is, iron sulfate is formed. The iron sulfate is transparent, and the copper is deposited on the iron nail. Is this reaction clear to y'all?
Yeah.
Okay. So this was the first displacement. Okay. Now this reaction took about, this will not happen instantly. Okay. It will take some time. It almost overnight I had kept it. Then we could see deposits of copper on the iron nail. Okay. All right. Now we'll move on to the next experiment. So in copper sulfate, what are we going to add? We are going to add magnesium, and let's see what happens. Okay, this is magnesium strip. So I'll be adding it to copper here. Not copper, this is, sorry, magnesium. I'll be adding it to copper sulfate. Magnesium strip. Can you all see some bubbles forming?
Yes.
Yes, ma'am.
Yeah. So there's some reaction going on. Okay. Now tell me, quickly look at your reactivity series and tell me what will happen. Tell me what will be the reaction. What is going to happen now? This is copper sulfate. We added magnesium to it. What is going to happen?
Magnesium will be replacing copper.
Okay. So magnesium will replace copper. See, you can see there's a slight change in the color. It's not entirely blue now. The color has changed a bit. It's
It's a bit
becoming
greenish.
Is the color change visible to everyone?
Yes.
Yes. Yeah. So magnesium sulfate will be formed and copper will be displaced. After some time, we'll see some deposits on the magnesium, okay? It has changed color. It has become a dark green color. So let me show you. Let us keep this for some time and let me show you how magnesium strip looks before and you will see it how it looks after. Okay. So this is how magnesium will look. Is it visible?
Yes.
Okay. Now we'll see after some time what happens. There is already some deposits. I have to remove it to show the magnesium strip to y'all. Y'all can see already see the change in color, right, everyone? Because the color of copper sulfate is blue. This is the blue. And you all can see the change in color already. Yeah?
Yes.
Yes.
Okay. Okay, let me show it to you all. Just give me 1 second. Okay. I'll remove the magnesium and show it to you all. I don't think you all will be able to see it. Swapna, should I show it? Show this part through the phone? Because I don't think they'll be able to see the change in the magnesium strip because there's no deposition till yet.
Basically, for the deposition to happen, it will take a little
It will
while.
take some.
Yeah,
Yeah.
it will take a little time. So right now it must be in the stage of displacing copper. So all the copper will get displaced from the solution, and eventually it will get deposited. So it has to be left undisturbed, the way we did it with the iron nail, the same way.
Yeah. So I can click the picture and show it to them later on, I think.
Yeah, sure.
What has Yeah. So I'm keeping it now.
The reason you all saw, like Nicola ma'am said, the iron and the copper sulfate reaction, ma'am had kept it yesterday and she got the results today. But in case of magnesium, you could see that the solution changed color instantly. Because, and there's a reason for that, why this reaction took place faster as compared to the previous reaction. So what do you think is the reason for that? Why the magnesium reaction happened faster than the iron and copper sulfate reaction?
Come on, think and say. Look at your reactivity series and tell ma'am the answer.
Where is iron in the reactivity series and where is copper? Where is iron and where is magnesium?
Iron and magnesium.
Yeah, magnesium. See, magnesium is very, very reactive as compared to iron. Iron is reactive than copper. But then when you see magnesium is far higher in the reactivity series. So magnesium is very, very reactive as compared to iron. So whenever we added magnesium to the copper sulfate solution, it reacted quickly as compared to the iron nail. Okay, this is the reason that the solution changed color very fast. Do you all follow?
Yes, ma'am.
Okay. All right.
All right. Now we saw two reactions, two displacement reactions. The first one was copper sulfate with iron, and you had seen the copper deposits on the iron nail. Okay. The second displacement reaction, we tried it with magnesium strips, and you had seen there's a color change. The blue color changed to dark green in color. Okay, and I'll be showing you all what it looks like after a few hours. All right, now we move on to the third experiment for the day, that is predicting activity series. So we'll see which one is more reactive and which element is less reactive. So I've taken three beakers. Okay, all are having copper sulfate solution. In one, I'll be putting iron fillings. In the other one, aluminium foil. We need to see which one is more reactive and which one is less reactive. In the other one, we'll be testing it with magnesium. So one iron fillings, one aluminium foil, and one is magnesium. Okay, so we'll do that. So these are iron fillings. Okay. The next we'll try with aluminium foil. And the third one with a magnesium strip. Okay. Can you all see any reaction happening? Any bubble formation taking place?
You have to bring it a little side.
Ma'am, bring it in front of the camera, please.
Is it okay now?
No. Little higher. Little higher. A little bit lower.
Is it okay?
No, it's still not clear. Kind of better. Yes, the bubbles are visible. Do you all see the bubbles?
Yes, I think those are the bubbles.
If I bring the cursor near, the screen is changing. So below the 50 line, like if you can see. Ma'am, take it a little higher, ma'am.
Okay. Is it okay now?
Little towards you. Yeah.
Bit of it.
Yeah, we can see it. Yeah.
Okay. And see aluminium. Can you all see any reaction happening?
Yes.
There is no visible reaction happening here. Okay.
We can't see anything. Yeah.
I can only see some bubbles. Very small and some foil, and it's a little blurry. Is it in my end or it's very blurry, the picture?
The picture is not blurry, but
Okay,
there are no bubbles. There are no
probably
bubbles.
something on my end because it's very blurry and everything is just moving a lot.
No. It's the picture is clear, but it's there are no bubbles. The solution is very stable. We don't see
Stable. Yeah.
anything.
What about the iron?
We can't see any bubbles in iron either.
Yeah. So tell me, from these three reactions, which metal seems to be the most reactive?
Magnesium.
Okay. Magnesium is the most reactive. Okay. Out of aluminium and iron, both look stable. Okay. But we then need to see the change in color. If you all can see any change in color in both the cases, how are we going to say which is more reactive and which is less reactive? Can you all see any possible change in color?
Iron filings are more reactive.
Yeah.
Oh no.
Can you see it has changed a little bit of color. It's not completely blue. It's the cyan color, but I don't know whether it looks like that. It's a greenish blue.
Yes.
Okay. Can you all see it? See, compare both of these. I think it looks same there, but actually this one is a little bit of greenish blue. It has changed a little bit of color. It's not completely that copper sulfate color. Okay, a little bit of greenish tinge is there in this beaker. So wherever you observe a color change, because we according to our experiment, we could see bubbles here. Okay, but so this is more reactive as compared to the other two. But when we try to compare these two, there's a slight color change in this. After some time, we will notice the color change more in case of iron filings, okay? But in case of aluminium, it just looks still. There's no reaction or no color change even. So it looks still. So aluminium is the least reactive. No, I think. Sorry. Yeah. Should I show this with my phone? Because bubbles are on the aluminium foil. And
Okay.
I think they cannot see it.
You
It's on the.
you can connect through your phone also simultaneously.
Yeah, I'll do that. Because the bubbles are on the aluminium foil. Okay, it's on it.
So what does the reactivity series say, girls? Which is more reactive, iron or aluminium? Students, please refer your reactivity series and tell us which is higher. Is iron higher or is aluminium higher in the list?
Aluminium.
Aluminium is higher.
Yes.
Okay. So let's observe what Nicola ma'am has to show.
Yeah, just give me.
Yeah.
I think it's still not visible. Is it visible? Are some bubbles visible on top of the foil?
Yeah, see the faint, the round bubbles where I'm pointing the cursor. Can you see that? Students, is it visible to you all?
Wait 1 second. Let me adjust it. Can you all see it? Or still not visible?
It was.
When you see it closely like this, it's visible to me. Wait 1 second.
I can't see a thing. The whole screen is blurry for me. It's just.
Can you try rejoining once?
Yeah.
Is the screen blurry?
No.
Better now.
Are the bubbles still not visible, right?
It is just. I mean, if you can keep the phone stable, we'll be able to see. I mean, these small dots that you see inside, which are little darker in color, are these the bubbles?
Yeah.
Okay. Children, follow the cursor. Okay. The point where I'm pointing right now, you would see the color is a little darker than the color of the aluminum foil.
Yeah.
Yeah.
Okay, so kind of bubbles arise, but those darker ones are the, see how I'll remove the aluminium and show it to you all. Okay, how it looks. so that you all can know that there was some reaction that happened. One second. Can you all see some deposits? Can you all see some deposits inside? May not be visible. Let's see what has happened to the iron, sorry, not iron, to the aluminium foil. I'm opening out the aluminium foil for you all. Can you all see it?
Oh, it's like it's eroded.
Yeah.
Do you all see, children?
Yes, ma'am.
Can you all see the holes that have appeared on the aluminium foil?
Yeah, yes. It's
Okay.
visible
So,
clearly.
yeah. So there was some corrosion. Okay. It happened because of the copper sulfate. After few hours, it will completely, there will be some reaction which will be visible to us. Okay, but still it is visible. You all have seen what has happened to the aluminium foil, right? And iron will take more time. Okay, I want to show you all. Can you all see any reaction in the iron? Can you all see some bubbles? Children, can you all see anything? Any bubbles? Any movement? Am I audible to anyone? Hello?
Ma'am, you're audible.
Yeah, so why are they not responding? Is it visible or not? That's the question that I asked them.
Could you just repeat it, because I due to internet problems I left the meeting and then I rejoined.
Yeah, I was asking, is there any bubble formation? Can you all see any reaction taking place? Can you all see some movement happening inside here?
I don't know.
We can see bubble formation definitely, and we can see some copper colored structure floating on the solution. If you can see the cursor.
Yeah.
Can you all see, students?
Yes, ma'am, I can see that.
Yeah. So naturally, Nicola ma'am did not add any copper to the solution, right? She added iron filings. And you all know what color is the iron filing?
Black.
Sort of. Yeah.
Iron filings are blackish in color, but then you can see that there is some bubble formation, and you can see structures which are colored like of the copper color, which are floating, right? That indicates that there's some reaction taking place. Is it
Okay.
clear?
Is it? See, you can see something floating, right? And they are of a different color. That is the copper that is being formed. The copper that is being displaced. Okay?
Yes, the orange things.
Yeah, orange things. All right. So now we move on to the next experiment. Okay, there's one more experiment that um, we can try it with hydrogen, that is hydrochloric acid. Now we tried it with copper sulfate. Just give me few seconds. So we'll try it with hydrochloric acid now. Okay, we have to put hydrochloric acid and we'll put magnesium and iron. Okay, that will show reaction. Okay, now we can put iron fillings. Can you see the two beakers?
Yes.
Yes, I have put hydrochloric acid, okay? Dilute hydrochloric acid. Now into one I'm adding iron fillings. Can you see the iron fillings?
Yes.
Okay. And to the other one, I'll add magnesium. Or I can add this aluminium to test it, okay? Yeah, we can add a piece of aluminium foil. We just need to see which is more reactive. Can you see any reaction?
No.
Yeah. Till now, there's no visible reaction occurring. Might take some time. Let's check.
Nicola ma'am, till then we can ask them the question for this week.
Yeah. So you all can note down the question, okay? Is my voice echoing? Hello?
Yeah, I can hear you.
Okay. So note down the question. What are the conclusions that we draw? What are the conclusions that we draw from the reactivity series?
Ma'am, could you repeat the question?
What are the conclusions that we draw from the reactivity series? That's the first question. Have you noted it down? Jot down another question. Give one large scale application of the reactivity series. Have you noted down both the questions?
Yes, ma'am.
Okay. So it might take a little time. So what we can do is, when there's a reaction, I'll be clicking pictures and posting on the group. Okay? Because this is going to take some time. All right? So I'll be clicking pictures. See what has happened to the aluminium that we kept in copper sulfate. I'll be showing you.
Excuse me, ma'am. You gave 2 questions, right?
Yeah, I gave 2 questions. Can you all see what has happened to the aluminium foil?
Yes.
Yeah. So it has completely corroded. Okay, there you all can see it, and there are some copper deposits at the bottom. Right.
All right, so this brings us to the end of this chapter. So, students, do you all have any questions to ask? Any doubts?
No, ma'am.
No.
Okay.
Did you all understand the reactivity series and displacement reaction today?
Yes, ma'am.
Everything?
Yes.
Yes.
All right. Okay, so in the next class, we'll be discussing these answers. You all write down the answers, okay, research about it, find out the answers, and we'll be discussing about it in the next class. Okay, I'll be showing you all, see what has happened to the iron fillings. Can you all see something floating?
Yeah.
Yes, ma'am.
That is copper. Okay. All right. So see you all in the next class. Okay, complete the work assigned to you all. All right.
Yeah.
Okay, ma'am.
And the quiz for this chapter will be uploaded by tomorrow. So, tomorrow evening, you can attempt for the quiz.
Okay, ma'am.
Ma'am, I'm not able to sign in to the portal.
Okay, you all have 2 minutes. I can quickly show you how to do that.
I know how to do it. It's just it's showing that an account doesn't exist with that email address.
So, Janvi, you can do one thing. You can share your username and email ID with me. I'll just check it out, and I'll reset your password for you, so you can then kind of I'll give you a demo password, so you can then go ahead and change your password once you log in.
Okay.
Yeah, you can send it to me on a personal message.
Okay.
All right, thank you everyone.
Bye.
Okay.